and segment, perimeter of sector and segment. So this is a circle. If the center of our circle, this is called radius, this is called radius, this is our arc, this is our arc, we call it length of arc. So if you bring this out, you have what? This is our sector. This is our sector. This portion is the sector. Take note, this is the length of arc. So our sector has what? Radius and what? Length of arc. Then this is another circle. I just want to differentiate between sector and segment. This is a circle. This is the chord. Remember our chord. So if I cut out this part, I'm going to have something of this nature. So this is our length of arc. Remember, this is our arc. This is the length of the arc, and this length of chord. Length of chord. Length of chord. This line is called chord. So the length of the chord and the length of the arc, this is our arc, will give us segment. So this is segment. Then this is what? Called what? Sector. Take note how you differentiate between a sector and a segment. That is to say, if I cut out my segment from this sector, I will have a triangle. Remember, this is a segment. The segment is in form of plates. This is your segment, and this is the full section is your sector. The full diagram is your sector, while this part, if you remove the triangle, you get your segment. So this is a full sector. Take note, this is your sector. So we're going to be looking at the perimeter of sector and segment. Okay, let's look at perimeter of sector. Remember, these are sector from what we said. So perimeter simply means the distance around the boundary of an object. For example, this board, this marker board, the perimeter is the length. If you check the length, breadth plus breadth. So add up the boundaries of this board, you get the perimeter. So the perimeter of this sector is to add up the boundaries of this sector. So let's start with length of arc. We now have the length of arc, which is this plus r plus r. This will give us length of arc. R plus R is 2R. So these are formula for perimeter of sector. And remember, the length of arc is theta over 360 plus times 2 pi r plus 2r. So these are formula for what? Perimeter of sector. Remember what we said? We said length of arc plus r, which will give us length of arc. R plus r is 2r. Length of arc, the formula for length of arc is theta over 360 times 2 pi r plus what? 2r. So these are formula for perimeter of sector. Let's quickly look at perimeter of segment. Okay, perimeter of segment. So remember, the diagram of our segment is gotten from length of arc plus length of chord. Take note, these are length of arc and these are length of chord. So remember, we said that perimeter simply means adding what? The boundaries of any object. So if we add the boundaries now, so I'm going to add, we say length of arc, which is going to give us length of arc plus length of chord. Length of arc is given by theta over 360 times 2 pi r plus our length of chord is 2r sine theta over 2. 2r sine theta all over 2. So these are formula for what? Perimeter of segment. Remember, we said perimeter means you add the length of the arc plus what? The length of the chord. Sum of the length of arc and what? Length of chord. So it gives us what? Perimeter of segment. Okay, we're going to be looking at area of sector. We have been able to look at perimeter of sector and segment. Please, if you have not yet subscribed, try to subscribe on YouTube. If you are not following us on Facebook, we are on Facebook, Exam Focus Tutorial. Take notes, we're on Facebook and we're also on YouTube. Get our full videos on YouTube and other educating contents. Now, we want to just simplify length of chord, length of arc, perimeter of sectors, perimeter of segment. We want to differentiate it for you, make it simple so that when you see it, you identify it. So those formulas look alike, but they are not totally the same. If you know how to describe it in a diagram, you'll be able to tell us the formula. So look at it, this is a circle. So remember we have just discussed on perimeter of segment and sector. We want to look at area. Now the difference between perimeter and area, we told you that perimeter is the sum total of the distance around the boundary of what? Of an object, of any plane shape, of any object. Now take note of any body. Remember we have discussed on perimeter just to add up the boundaries, but now we are looking at area. Now what is the area of a sector? Remember our sector is bounded by length of arc. Length of arc, this is our arc. Then we have two radius. We have what? Two radius. So if we cut this out, we have that our what? Our sector is r length of what? Arc. We have our angle bounded here, angle subtended. So our area of sector is given by theta over 360 times the area of circle. Area of what? Circle. Which is going to give us theta over 360 times area of circle is pi r square. It's as simple as this. This is your formula for area of sector. We want to take an example on area of sector. There are questions like this. Sometimes they are wire questions and you will see things like this. They say calculate the area of the sector above, leaving your answer in terms of pi and x. Now take note, this is the sector given to us. The radius is x and the angle subtended at the center of the circle is 135 degrees. We are asked to calculate the area of the sector above, leaving your answer in terms. Please take note of the statement in terms of pi and x. So the question to ask yourself is in terms of pi and x, leaving your answer in terms of pi and x. You might be given such question to answer in your school as a student if you are in SS1. This term is all about length of arc, length of chord, perimeter of sector, segment, and many other solid shapes. Now, how do you address this kind of question that has to do with in terms of pi and x? Let's get started quickly. Remember, these are solution. We're told that our area of sector is given by, is equal to theta all over 360 times pi r squared. That is our formula. So what is our theta? The angle subtended. The angle subtended is 135 degrees. 135 degrees all over 360 times, we're told to leave our answer in terms of pi and x. What does that mean? It means you are not going to touch pi, so you bring down pi, and then s, which is r. We're told that our radius is s, which is s squared. We substitute r for what? X. We substitute r for what? X. So we have s squared. So remember, we're asked to leave our answer in terms of pi and x. So this is going to give us 5 here. 5 into 135. Quickly remember that 5 into 13 is going to give you 2. Remember what? 3 into 35 is 7. And then 5 into this is going to give us 72, because 5 into 36 is going to give us 7. Remember 1, you have 1 here, into 10 is 72. That is to give, that is to have pi s squared. Now we still need to break this down. 9 can actually go. 9 to 27 is 3. 9 into 72 is 8 pi s squared. This is your answer. It's as simple as that. That is your answer. Remember what we said. This is our formula. we're asked to leave our answer in terms of pi and x. So we have been able to leave our answer in terms of pi and x. Remember, we're told that our angle subtended is 135 over 360 times pi r square. So we'll replace it 135 times pi our x square. Remember, this x is substituting for what? Radius, which is x here. So at the end of the day, we'll have that 5 into 135 is going to give us 27. 5 into 360 is going to give us 72. And so when we divide both sides by 9, 9 to 27 is 3, 9 to 72 is 8. So I have 3 over 8 pi s square. So look at it. That's just very simple. In case you have such question in your exam, just look at how to evaluate. It's as simple as that. That is area of a sector for you. Thank you. Okay, quickly we want to look at area of segment. We just finished discussing on area of what? Sector. Area of what? Segment. We want to look at area of segment. Remember, segment is gotten by, you first of all have your sector. This is my sector. Comma. Remember that this is your sector. Your sector is gotten by length of arc. Remember, it's gotten from a circle. And then this is your radius. This is your radius. This is a sector. Now, this is my chord cutting the sector. So if you observe carefully, this part shaded is my segment. The shaded part is my what? Segment. So how do I get the area of a segment? Area of segment. Area of segment. Area of what? Segment. Area of segment is going to be area of sector, the full sector, area of sector. Then you subtract the triangle up. So if you observe carefully, if I separate this, I'm going to have triangle up and I have segment down. So if I subtract my triangle, I will have what? Minus area of triangle. Area of what? Triangle. Area of triangle minus area of triangle. So at the end of the day, what is our area of sector? We're told that area of sector is theta all over 360 times pi r square minus area of triangle. Area of triangle is given by half r square sine theta. R square sine theta. How do we get r square? This is your r square sine what? Theta. This is our triangle. Remember, half your base times your height. We were told that half base times height sine theta, especially for the one that have angle, because of the angle subtended over here, because of our theta. Remember, for sine, those of you that learn sine rule and cosine rule, you will discover that this is the area of a triangle with included angle. Take note. If there's no included angle, our formula for area of triangle is half base times height. But when you have an included angle, it is given by 1 over 2 r square, which are the size sine what? Theta. So these are formula for what? Area of segment. So area of segment simply means the full sector. You remove your segment, you get the area of the segment. You remove the triangle, look at it, the full sector, remove the triangle. This is what we are having here. This is the area of what? Of segment, the portion what? Shaded. So if I remove my triangle, this is the part I'm going to have. You can experiment this. Tear out a sector in a piece of paper and remove the triangle, you have segment. So if you look carefully, these are triangle and this is our segment. So that's how we got this formula now. We say area of sector, which is this, minus, which is cut out, the area of triangle, you get your area of what? Segment. It's as simple as that. We want to look at length of arc. Length of arc. This is a circle. The distance, okay. Watch carefully. This is a circle. This is the center of my circle. And this is the angle suspended here. Let's call it theta. And this other angle, let's call it beta. Are we there? This is theta, this is beta. Now, the distance from here to here is called arc. Take note, this distance, this curved distance is our arc. It is called what? Arc. We call it minor arc. Minor what? Arc. minor arc. This distance, let's call here AB. If you observe carefully, if I decide to split this, this other curved line, the bigger one, is called major arc. Major what? Arc. I'm going to do a separation so that you understand. So I say that this one that we have this way is called minor arc. Minor what? Arc. These are minor arc. This line, this curved line, is a minor arc. Remember, it's bounded by radius and there's an angle subtended at the center of the circle. So for a minor arc, let's call this C and D. That is our major arc. So our major arc, we'll call this CD. That is the distance from here. This curved distance is our major arc. Major what? Arc. This is our major arc. And so take note, what is, look carefully, this is our major arc. This is also the radius, this is the radius. Let's call here what? Beta. So I've been able to separate these two diagrams. So we have the length of arc is given by theta over 360 times circumference of a circle. Circumference of circle. Circumference of what? Circle. Which is going to give us, that will give us theta all over 360 times 2 pi r. That is the formula for length of arc. Circumference of a circle is another word for perimeter of a circle. If you are hearing it for the first time, circumference of a circle is the same thing as what? Perimeter of a circle. So theta over 360 times 2 pi r is our what? Length of arc. It's our length of arc. Take note, this curved line is what is known as arc. If you make a full arc, it gives you circle. A full complete arc gives you a circle. So from here, C to D is the major arc. Line A to B is what? The curved line. The curved line AB is what? Minor arc. While the curved line CD is the what? Major arc. Take note. We have length of chord. So length of chord, I want to look at length of chord. How do we get length of chord? This is a circle. If you have a circle here, this is our center. Now take note, how do you get the length of chord? This is diameter. The line that divides a circle into two equal parts is known as diameter. Please, I want you to differentiate between diameter and your chord. This is called diameter. But the line that is either above the diameter or beneath the diameter is known as chord. So look at it, this is what we call chord. It can be beneath the diameter. That means it's below the semicircle. That is below. If it's less than a semicircle or greater than a semicircle, it is called chord. So take note, these are chord as well. So this is called chord, this is called chord. So length of chord, how do we solve for length of chord? Length of chord is given by 2r sine theta all over 2. Now, if we draw this circle the other way around, we have the center of our circle. Remember, this is our length of chord. And we have our radius. This is our radius. And then we have a line drawn from the radius, from the center of the line to cut the chord. We have what we call perpendicular height. These are perpendicular heights. So if you watch carefully, we have two right angles formed inside the circle. Let's call here x and let's call here x. So by Pythagoras theorem, we can have that if you bring out one of the triangle, watch carefully, you have something of this nature. These are radius, these are height, and this is x. By Pythagoras rule, we are going to say that hypotenuse square, which is r square, is equals what? Opposite square, which is h square, plus adjacent square. So you use both formulas depending on the equation. When do we use this? When do we use this formula? I want to show you something. You use this particular formula when the angle subtended at the center of the circle is given. For example, theta is given. When you have theta given. If you have equation of this nature, this is when you use this formula. But if your equation is of this nature, you use this formula. Take note, both of them still talks about what? Chord. If you have a circle of this nature, use this because there's an angle subtended. Then if you are given this nature, you use Pythagoras theorem. This theorem, we call it Pythagoras theorem, where we say that hypotenuse square is equals to the square of the two other sides. This is the hypotenuse. Hypotenuse is the longest side of a right angle triangle. This is the hypotenuse. We have opposite and adjacent. Remember, the right angle triangle has three sides: hypotenuse, opposite, and adjacent. Hypotenuse is the longest side. We have the opposite and we have adjacent. So these are the two formula for length of chord. So length of chord has two formula. Remember, this is the length. This is what we are calling the length. This is our chord. This is our chord. So by the time you have been able to solve for one on the side, this is x. Let's call this x1, x2. So if I'm able to get x, I will multiply by 2 to get the full length. Because if I draw out one of the triangle, by the time I'm able to get this length and I will add up this, I will have the full length of the chord, because this is the chord. This line is what we call chord. Thank you. Remember to subscribe if you are here to subscribe on our YouTube channel. If you are following us on Facebook, please like, share, and comment.